Question number 42?
Yeah.
On page
245.
245? Oh, sounds familiar. I can't remember we did this in class. Did we?
I don't know.
It does sound familiar, but I never know if it's in class or with somebody individually. The thing you got to be careful about there is calling one of them larger and one of them smaller. And it's, so smaller is X, larger Y, and then set it up exactly. So you got to be careful because the order will matter when you take the difference.
Yeah.
Does that make sense? Okay. So we went over that one yesterday. Anything else from the homework? Bless you.
Thank you.
Okay, all right. Let me do this. We're going to get into polynomials. We're going to talk about what the hell is a polynomial, some parts of polynomials, some definition stuff, how to add them, subtract them, multiply them. We'll do division later. But let me go ahead and give you this practice test. If I'm talking about something on the board that you completely understand, this will be something for you to do instead of sleeping. And I'll have the answer key for this tomorrow.
Is this a homework file?
Sort of. There's a bigger one right there, yeah.
Oh, this is a turn-in homework file?
Yeah. Just to make sure everybody's on the same page, somebody just asked me a question. Are the quiz corrections and test corrections always due by the day of the next test? So you can give me today, tomorrow. You got to give them to me by Monday. Otherwise, you can still turn them in and still get some points back. They'll just be late, and you'll get fewer points back than you could have. Yeah.
I need another picture.
Oh. All right.
Some of the for the points back on the quiz, like if you just didn't, like something that you did all the work, but like I just remember I didn't write.
Oh yeah,
so I can get that one.
If there's
point
ever
back.
something that I took some points off, but you did everything right until the last step, you can just start right at the last good step. Does that make sense? You don't have to redo the whole damn thing. You just have to start the last place that was good and then do it right from there.
Okay.
You don't have to redo the whole thing.
All right.
Good. Cool. So we're just going to get right back into it. We left off, we did 5.1 and 5.2. And the last things we did were the big, ugly looking, just full of letters and numbers and negative powers and so forth, how to simplify those things. And let me start off with a little review of that. Let's try a problem out. And I'm not going to make it as ugly as yesterday. I'm going to make it as ugly as you'll see in the book. So try this one out here. Simplify this. So this kind of problem, where do you start off? What do you do first?
Change the value or simplifying.
Cool, right? Go for your numbers. Go for the easy part first. You can reduce this. What's that become?
1/3.
Yeah, 2/3. And then what do you look at next here? Yeah, you could either start just applying the division rule where you subtract the powers. But my extreme suggestion to make it a little easier is anything with a negative power is just going to go to the other side. So you've already got 4 up there. Those 2 x's are going to come up. And what's going to happen with the y's? Yeah, both of them just switch places. He doesn't like where he is. He didn't like where he is. So they just switch. So what do I have? How many x's do I have up here? 6. And then how many y's are left where?
-2.
Be careful now. It's either 2 at the bottom, or 3 minus 5 is y -2, which would flip to the bottom. You don't put y -2 on the bottom. That's like a mixture of the ways to look at it. You guys kind of with me? Yeah.
I'm just confused on the y. So, how do you get y to the y squared?
How many y's are on top?
3.
3. How many at the bottom?
5.
How many cancel?
3.
How many are left?
3.
Where?
And that's because it's 5.
I love that approach. I would not be writing the y's out like crazy, because I might give you y to the 80th over y to the 112.
Can you repeat that? It's going to be positive or positive, but...
There's 2 ways to look at this. The way that I just did, or just looking at this piece by itself. What's the property say you're supposed to do with those powers?
Okay.
Subtract, right?
Subtract.
3 minus 5 is
2. Okay.
-2. And then those would flip down. So either way you do it, it's the same. Don't do both things. Don't say there's 2 left at the bottom, but when you subtract, you get a negative. You've just done both ways at once, and that's pretty much almost always going to end up with the wrong answer. You pick a way that you like better.
Why would the -2 though go down at the bottom?
What's a negative power mean? Flip. Why were you cool up
No,
here?
I mean, why do you bring it up to the top anyway? Why would you bring
I didn't bring it up to the top.
With 3 minus 5, right?
Yeah. What's x to the 8th divided by x to the 5th?
X to the 3rd.
X to the 3rd. No question, right?
Yeah.
Why is it on the top? That's not even a question I would ask. So what's x to the 5th divided by x to the 8th? Well, 8 minus 5 was 3. But here, 5 minus 8 is -3. But what would the next step be on this? Bring it down.
So you just assume it's on the top?
No, I just know it's on the top.
Alright.
Because the property says the answer is going to be x to the subtract these powers. Yeah. Okay. So you got to pick a way, right? If you do this subtraction, the answer will be on top, because that'll be just the straight up answer. This way is, I like it a lot better, and normally what that means is it requires you to do a little bit more in the head, right? Because then things are a little quicker that way. But all you have to do is realize 3 of these y's are going to cancel. 2 of them are left on the bottom. Right? If you can do that, that's cool. If you don't like that, you could do the 3 minus 5 is -2, and then they'll flip. You'll still get the same answer. Yeah.
Can't you just think of it as, no matter what, it can't be a negative, so it's going to have to go on the opposite top of the x one.
That kind of rule won't help you in specific situations. How much is left, where. You see what I'm saying?
You mean like, does it originally go on the top or does it originally go on the bottom?
Yeah, I mean, that would, if you think that way, you got to combine both methods then almost. I know there's 2 left on the bottom just because that's where more were. I don't need to ever realize that it would have been a negative power on the top. I just know there's 2 left on the bottom. That's all I care about here. But see, to make it consistent, really, if I do 3 minus 5 and get -2, it's got to be the same answer. That's another reason why negative means flip, to make it the same as what I would get this way. Okay.
Can you do another one like that?
Oh, yeah. That I got that impression.
Can we just do the best of
I don't know if everybody would like that. Yeah. Let's see. All right, so try that one. I'm going to try to do this one two different ways, which almost always gets me in trouble. That's too bad. For some reason, I'm just going to do it. The first way I'm going to do this is very directly by the properties. So this is not the way I would normally do it myself. Both methods really do the same thing here. What's that reduced down to? 4 over 3. Cool. And then here, using the properties directly, -4 minus 9 is -13. 8 minus -3 is 11. -7 minus -10 is -7 plus 10 is 3. And then you flip that down, because that's a negative power. Yeah, so the last part of it would be D11, C3. Yeah. Yeah.
So for C3, well, I got C3, but mine's at the bottom. Why is that wrong?
I should answer that. Because that's not what you get. You don't have 3 left on the bottom. Let me do it the other way. This is the way I was showing you earlier. This way, it's so easy to make negative mistakes or have things end up in the wrong place. If I do it the other way, I can reduce this like we just did. These 4 go down. Let me see if you guys can do this. If 4 go down, there's 9 there already. There's going to be 13 of them. These 3 go up. There's 8 there already. 3 more coming. 11. Both these switch places. So then I just have one cleanup step. How many C's are left? 3 up on the top, because that's where there were more of them. Either way, I get the same answer, right? Yeah.
So the only time you would move
The numbers?
no, like the problem I had was where the A's were. I thought the 9 went up.
Is the 9 in negative power?
No.
No. So he's not going to go anywhere.
So only
Identify the
negatives.
ones that have negative powers are the only ones that are going to flip.
And if there's 2, then they just switch places.
Yeah. These both happen to be negative, so they end up switching places. But don't think switch places. That's what leads to these going at the same time. They're both negative, so they're just both going to go to the other side. That's all. each thing that's to a negative power goes the other way. So either way you want to do it, whichever way makes more sense, I love it. They're both valid ways to do it. I personally like this way better. It just makes a little more sense to me, and it keeps me away from negative mistakes. This way works perfectly well. Just using the property directly, they can't possibly be bad. So it's really easy to make negative mistakes here. That's when people start to do this, is where I start getting A5, B5, the 3 C's in the wrong place. I mean, that's the kind of errors I get from this method. Please tell me one of these two methods makes more sense. Okay, maybe. All right. So, and the very, very last thing we did last time was scientific notations. Let me give you guys one of those to try. Well, two problems. Psi naught is scientific notation. Convert to pure number form or decimal form, however they want to say it. So these are either pretty quick or just you'll never get them. You know how this works or you don't. What do I know about the power on the answer here? What's the power going to do? It's going to be negative because it's a small number, right? How many times do I have to move the decimal? 1, 2, 3, 4, 5. I always have to move it until I get a single digit right in front of it. So then I get 3.107 times 10 to the negative fifth. Negative because it had to move from a small number. Fifth power because it moved it 5 times. So think about what this really means. Wouldn't those 5 tens go down because they're negative power? So then you do this divided by 10 to the fifth. That's why it gets small. That's why thinking small number, negative power, those go together. They mean the same thing. Makes a lot more sense than freaking left and right. What about this guy? So that can become a big or small number? Big freaking number, right? How many zeros are you going to end up? 10. You're going to move it once, twice, and then 10 more times. And each of those movements is going to show another 0. 1, 2, 3, 4, 6, 7, 8, 9, 10. Yeah, it's he's lost some money. He's lost more money than I'll ever make my whole life. Oh.
Can you do some of the experiments with distributed properties also?
How do you mean? Oh, the oh, you mean like this here? Like That? So you pretty much just gave yourself the answer. This is distributive property for exponents. Right? So coefficients distribute across subtraction and addition, no problem. Exponents go across multiplication and division, no problem. So what would this become? Good. 2 cubed is 8. X to the
12.
Beautiful. 12, not 7, not 64. Y to the 24. Multiply powers when you raise them. Add powers when you multiply. Right? Yeah.
What about like multiplying the scientific? There's some in the book.
Oh yeah, we're doing that next.
Okay.
Go on. Yeah.
So you, for 8, to get the 8, you just do 2 times 2 is 4 times 2 is 8.
You got it. Because 2 cubed means take 2 and multiply it 3 times. 2 times 2 times 2.
You only cube the whole number, and then you just multiply.
Now be careful. I am cubing every single one of these.
So the X is actually cubed.
And to tell you completely honestly, there's a step I skipped here. The numbers can go further because I actually know how to multiply numbers. But what's x to the 12? I have no freaking idea. But now, now watch. Let me look at this a different way. What's the power on the 2?
1.
First power, right? You would think first. I haven't brought the 3 in yet. What do I do with every single power? Multiply. Because I'm raising them, right? I would multiply if I was... I multiply here, and I would add them if I was multiplying my bases. That would be addition. Here I multiply them. So what's 1 times 3? 3. 4 times 3? 12. And of course the 24. So you see, I mean, if you write them in the same form, they have to act the same way. Does that make sense? I mean, that's really what's going on. There's a first power, so 1 times 3 is 3. But I can just go further with this. I know what 2 cubed is. I don't know what the hell these other things are. But 2 cubed is 8. Cool. I like it. That's exactly what we're talking about. The math can't do 2 different things just because it feels like it. It has to do the same thing. It's just that numbers are not going to end up acting the same way that these do because they aren't written the same way. They aren't in the same form. There is no 4 in here. There is no 8 in here, but there's a 2 in there. All right. And then one more of these. If I had... So, don't just because I wrote this down, like, is there anything to do on the inside? So it's not that kind of problem, right? It's a little more direct and to the point. There's nothing to do on the inside. There's just one thing I got to do then, really, is apply that power, and it distributes to everything. Cool. Just like if I had a 3 sitting in front of a really long, plus y minus z plus 2x minus w. Wouldn't the 3 just go to everything? That's exactly the same situation. It's a really nice analogy. So what do I get here? The 2 to the 3rd power is 8. Good. X to the 21st A12.
125.
Good. 125. Y9. Z15. Okay. Not too bad. And there's nothing common to cancel out, so I'm done. Okay. So now I want to answer somebody's question about things you can do further with scientific notation. And I think I'm going to move up to this guy here. So I'm going to look at some stuff out of the blue book. It's on page 72.
You want to move this?
Oh yeah, thank you. Let's forget this poor dude. Page 72. We're doing battery. All right. There we go. Sweet. Ooh, yeah. That's awesome. There you go. Okay. So this is kind of like the next level of what you can do with scientific notation. The minute we write things in scientific notation, we've got a part of it that has exponents. So when I want to multiply these scientific notation things together, I can use properties of exponents on that part. So for example, that very first problem, do you see how everything is multiplication, right? 2 times this times this times this. So what do you think I can multiply together?
2 and the 4.
Yeah, the 2 and the 4.3, I can multiply those, and what do I get? 8.6. And what do I get for the tens? What am I going to do with those powers when I multiply those tens together? You're going to add them, which basically means subtract, because one of them is negative. What's 5 and minus 9? Negative 4.
Don't you do exponents first, though?
When I'm doing this, I like that question. When I do this, I have to do exponents first, but what is x squared? I don't know. So then I go straight to multiplication, because there's a rule for how to multiply with exponents, right? So these tens, I don't want to write 10 to the 5th what it really is. So I just want to keep it like a symbol. 10, 5 tens, negative 9 tens, and there's a rule for doing that. Does that make sense? So, yeah.
10 times 10, 100.
I love it, but I'm not doing 10 times 10. I don't care. No, there isn't. You pretty much just answered your own question. Are there 2 tens? No, there's 5 tens and negative 9 tens. So how many tens at the end? Negative 4. So I will never multiply those bases together because the exponents are keeping track of how much multiplying I have to do eventually. I'm not doing any multiplication yet. You kind of with me? So if I had to do 8 times 8 times 8 times 8 times 8, I don't feel like doing that. Let me just say there's 8 to the 5th, and then I'll worry about it later. Just keeping track. And then if I have to multiply 2 more 8s, all right, well now I get 7 8s. So later I'll worry about that, right? Does that kind of make sense? All right. Okay, so now we hit already our first little speed bump. Now, let's see if you guys see why. Is this answer okay as far as is it still in scientific notation? And how do you know it is? It's got a 10, it's got a power, it's got the times, but more importantly, how many digits in front of the decimal? 1. If I didn't have that, it's not in scientific notation. Now, for some reason I brought that up. It's probably got something to do with number 2. So how do I do number 2? What do I do first there? Yeah, what's 6.1 times 4?
24.4.
And then I get times 10 to the what? 5th. I love it. 8 plus negative 3.
Well, are you going to pull the 10 out of that 24.4?
Beautiful. I love it.
then
So I look at it and I say, this can't be right. I had scientific notation times scientific notation, and now I'm not in scientific notation anymore. You say that often enough, it sounds weird. So, just like you said, I kind of do it a different way, but the most direct way to do this, put that times 10 to the 5th on the side for a second. Now look at this guy. How do you write just him in scientific notation? You have to move it back once, right?
Times
So 2.44 times 10 to the... No. 6. You're getting ahead of me. This would just be 1, all right? Why? Because 24 is big.
Negative.
A negative power will make me go back, right? So think of this in reverse. I'd have to put a positive one there, so somebody would have to realize, oh crap, I got to go this way to make it back to what it was. If I start with a big number, and 24 doesn't sound big, but it's big relative to 10. If I start with a big number, I should have a positive power at the end, right? If a negative power, if I had 2.44 times 10 to the negative 1, what does that negative 1 tell me to do? Take it to, oh, it's going the wrong way, right? I wouldn't get 24.4. 10 to the first, which is times 10, but we just put the 1 up there to make it part of the format. Same thing as that. I just put the 1 up there so it's part of the format.
Would you take it without the power, or does it have to have the power?
With the power. And then what do you get? Now you can do this. 2.44 times 10 to the 6. Now just in case some of you guys can understand the way I do it, because obviously the way I do things is not always the easiest to understand, but I look at that I look at 24.4 times 10 to the 5th. How many, that 10 to the 5th, that wants the decimal to move how many times? 5 times that way. So if I push the decimal back once, now the poor dude has to move it 6 times that way. Bam. So if I move the decimal back once, and that dude wants to go that way 5 times, shit, now he's got to go 6 times. So I just reason it out. But you can always do that middle step. Take that part that's not a scientific notation and convert it. And then just put your 10s together. That will always work. Yeah.
How is 24.4 not a good answer?
Can somebody tell me why is 24.4 telling you it's not good? It's not scientific notation.
You only have one number.
You can only have one digit in front of the decimal point.
Okay.
24 has a 10 in it, doesn't it? 2 10s and a 4. And the whole idea of scientific notation is take all the 10s out and put them all together. So see how that 20, now here's a whole other way to look at it. 24 has 1 10 in it, right? 20. So I took that 1 10 out and put it together with the other 5 10s, so now I got 6. So that's really what happened in the math. I sucked that one last 10 out. Yeah.
Could you do another one?
Yeah. Oh, yeah. So on this one here, you actually do it the same way, believe it or not. We'll do these two. These are almost the same as what we just did. What do you think you do first here?
Divide the number.
Yeah, the numbers. 9.6 divided by 3. Good, 3.2. Now here's I want you to realize, the notation will force my tens always to the top. You with me? So when I'm doing scientific notation, I don't care what the exponents are. I force everybody up to the top. Why the hell would I do that? Because I know the answer wants all my tens on the top. So I'm going to take these two tens, and they want to go there anyway. Cool. So when I move them up, what does it become? It's -2 now, so when I move it up? 2. And what's -6 and 2? There you go. And is it good? Is it an okay answer? Yeah, because my 3.2 just has one digit in front of the decimal.
Why doesn't the 6 move down?
It could. And if I did that, okay, so if I did that, here I got 3.2. And let's say I move these 2 tens up, and I move these 6 tens down. What's 2 minus 6? Same thing. Yeah. Oops, sorry. But you guys understand, scientific notation is a specific application of exponents. So we know how exponents work. If they're negative, they flip and so forth. But for scientific notation, all the tens want to be up top. So I just push them up there. If it's a negative power, it's going to become positive when I put it up. For this next one, what tens do I want to move? The 7. Now, no, they're not to a negative power. The only reason I'm going to push them up there is because my notation wants all my tens up there. But when I move them up there, what's going to happen to them? They're going to come negative because I want to tell people, this door just moved me up. I want to go back down. Right? So these 7 tens would come up. Now somebody help me out. What's 1.8 divided by 3?
0.6.
0.6. Good. Times 10 to the
-3.
-3. Good. And another way to do that is just, what's 4 minus 7? -3, right? Just a little more direct. But me, I just always push all my tens up. Is that okay?
No, you got 6.0.
Good, right? I don't have a number between 1 and 9 in the front. I need to move that decimal once more over there, right?
You have to have.
You have to have.
0 as a placeholder.
How do you say 0.6 is a fraction?
6/10.
6/10. It's got a 10 in it, right?
Yeah.
So my scientific notation hasn't sucked all the tens out yet. You guys kind of with me? There's still like a 10 to the -1 in it. Isn't that 6 over 10? Isn't 0.6 6/10? So there's still another tenths to pull out. That first number in front of the decimal, it can only be one number in front, and it's got to be 1 to 9. 0 is not considered a number. That's like the absence of a number. It's just holding the place. Because remember, I could not write 0.6 like that.
Like what?
Oops.
Yeah.
Right? I could write 0.6 like that. Why do we put the 0 there? Just to make sure everybody sees the point. So there really is nothing there. There's no digit there. So the more direct way to do this, how do you convert this into scientific notation?
6.0.
Good. 6 times 10 to the -1. Good. Right? Because you came from a small number to a bigger.
Well, you only move in one place. Why do you change? Oh, what? Okay.
Oh.
It's still not done.
I don't understand
No,
why
still
you
not done. I know.
Why wouldn't you get -2?
Oh, you will.
Why is
He's
it
just
negative?
writing it.
No, I won't.
No, no.
What?
No.
-4.
It's going to
-4.
be
Yeah, that's
-4
fine.
because you moved one more.
Exactly. So again, when I start with a small number, when I move the digit, it doesn't become a negative power, right? Check yourself. What would this -1 mean? Move the decimal back. Wouldn't I get back where I was? So then what's 10 to the -1st, 10 to the -3rd? Beautiful, -4. I like it. So you should all be able to get this first step. Hopefully that's not too big of a deal. But the only trouble you have is going past that. If that doesn't end up in scientific notation, I could work with that. Right? If you can't do the first step, that's where we have some issues. Let's try a couple of, just a couple of moving decimal stuff problems around. Like if I did a problem and I ended up with 103.7 times 10 to the 14th. Is that a good answer for a scientific notation problem?
No, sir.
No. So, you can always attack that 103.7 number. Move the 14 out of the way for a second. That's still there. But just focus on this now. How do I write that in scientific notation? 1.037 10 to the second power, 11. Right, because I started with a big number. It's going to be positive. When I say big number, I mean bigger than 10. When I say small number, I mean smaller than 1. So what's up? Everybody cool with that? That's just if I gave you the problem 1.037, can you make that, 103.7, can you make that into scientific notation? Yeah, move it back twice, there it is. Then you got those 14 tens just sitting out there, so you can put these together, what do you get?
16.
And just to remind you guys, I would say he wants the decimal to go 14 that way. I move it back twice, and he's like, screw you, now I got to go 16 times. So I skip this step and I just kind of reason it out. So you can always do that if you like that. Or you can do this for yourself so you can see exactly what the hell's going on. Let's try another one. What about if I end up with
4.
Alright, so this, move that 10 to the 5th over here. This would be 1, 2, 3, 4. 7.6 times 10 to the good, negative 4. Good, and then you just do this. 7.6 times 10 to the first.
Well, we have to.
You would know that right away though, because there's only one number. There's no more zeros.
I know, you guys keep trying to get away from that, but this is one case where the format wants that to show up. It's normally understood. But if I write this, it just looks weird to me. Those mean the same thing, but it's weird. I know it's probably just to me, because I'm the one in here that's probably most used to scientific notation, but that just looks weird to me. There you go, now that feels better. Means the same damn thing in mathematics, but that's the format for scientific notation.
That's called the exponent.
Say again?
1.
Yeah, show that exponent, even if it's just a 1. I like it.
But going to the right or backwards, isn't it always going to be just 10 to the first because you're going to stop in between the whole number and the tens place?
Well, it depends on how many movements it took to get there. Remember that 0.00076 itself is 10 negative 4. The only reason it was 1 at the end is because I already had 5 10 sitting over there waiting. Is that cool?
Yeah.
But it took 4 motions to get there. That's why it's negative 4.
Okay.
And the other 5 10s that were there from the beginning makes it 1. Is that cool?
Yeah.
Okay. And again, the way I would look at that, as I kill myself, this wants the decimal to move over this way 5 times. I move it that way 4 times. I've done some of its work, right? So how many steps does it have to take now? 1. That's the way I wouldn't do this step myself. I would just think, it wants to go that way. I went that way. It's got less work to do. Bam. So either way you want to do it is fine. Okay. When you get to your science classes, if you have any science classes in your future, you will appreciate the fact that we have talked about this. If you don't currently appreciate it. Alright, so let's move on. Math people and their words, I know, but polynomials, whenever and this isn't just math people, obviously, a lot of people, whenever there's a word that people define for their profession or for what they do, it must mean something. There must be a reason we brought it up, and it's not just to terrorize students. But when I say I have a polynomial that I'm working with, if I said that to one of my colleagues, what they would know is they could plug in any value they want to. So polynomial somehow is nice. It's got no problems anywhere. So let me show you an example of a function that has a big problem. That just sounds weird. This function lost its dog. No. Can you explain to me why, where? There's a spot, there's somewhere that this guy freaks the hell out. If I try to plug a certain value in, it's going to just go to hell. It's not going to know what to do. 1. If I try to plug a value of 1 in here, I'll get 1 over 0, which is undefined. So a polynomial somehow never has this happen. So for one thing, then, we know that if it's a polynomial, there's no way that a variable is going to show up on the bottom. You with me? This is not a polynomial. How are we doing so far? Is that okay? So another not a polynomial. Here's another not a polynomial. These are not polys. 3x squared minus 1 over x. The first part's okay, but then here there's a variable on the bottom. Goes to shit. What's wrong with this one here? Has no name. How do you mean?
No special name. It has more than 3 characters.
Oh, it only has 3 actually. You're a little ahead of me.
Trinomial.
Exactly. This would be a trinomial. I'm not quite there yet. This is not even a trinomial because it's not even a polynomial. Why is this not a polynomial? Which y specifically? Yeah, this guy. It's got a negative power, which means it would have a y on the bottom. So to generalize this idea, a polynomial can be any collection of terms, and terms are separated by pluses and minuses, where every single variable is to a whole number power. I can't have negative powers. You with me? And if it's on the bottom, that means it would have a negative power, right? And you can't even have fractional powers. We don't even know what the hell fractional powers would be. So that's a good thing. So polynomial can only have whole number powers. So this here, of course, this looks disgusting as hell. So maybe don't look at that. That's their attempt at generalizing what the hell it could look like. So an example of a polynomial, there's a polynomial right there. Why is that a polynomial? All of its variables have whole number exponents. I love it. At the x.
Does that negative 6 have anything to do with it? On the board.
Over here? Oh. No.
Just the exponent.
If that wasn't there, the rest of it would be cool.
Okay.
So the rule is can have no fractions and can have no negative.
Now be careful. If I had more white space, well, here we go. If I had something like this, you guys read that? It's x squared plus 1/3 x minus 2. Is there any variable that's on the bottom? No. It's got a fraction in it, but that fraction does not have a variable on the bottom. Is that cool? So it's only if a variable would show up on the bottom. And why would we throw that out? Because then it might have spots where I have a value I can't use.
Can you write one that will compare what you're saying, please?
Sure. So this is good. Check. This is bad.
It's because 1/3 is still above 0, right?
That's bad.
So a variable is an unknown number.
Yeah, variables are unknown. So the numbers I don't care about. Why would 2 be better than 1/3? It's not.
It's negative.
They're just numbers. All I care about for the definition is, what are my variables doing? And really, it's because, can I control that 1/3? No, it's just freaking 1/3. I can't do anything to it. But I can control the x. I can make it whatever I want to. That's why it's important what's on the x. Here, can I make x anything I want to? No. Because it's on the bottom. Here, can I make y whatever I want to? No, I can't put a 0 in because that would be 1/0. You with me? But the numbers, I don't care about. They're 4, they're 6, they're fine. I'm cool with 4 and 6. I'm cool with 1/3. Right? It's a fraction, but it's still a number. It's fine. It's just the variables that I have to look at. Okay.
So if that was 1/5 minus 2, it would be fine. Just can't have a
Yeah, that would be fine. That would just be 1/3. Yeah. Right? It just can't have a variable in the bottom. Yeah. Or a negative power. I mean, this would be bad also if I had 5y cubed w minus 2w plus 3y negative 2. That's bad. Because it's got a negative power. It's got a negative power on the y, which would put the y on the bottom, and then there's a value I couldn't use. So one reason we have this word is it's a very quick way of me telling somebody, I've got something, you can put whatever value you want into it. If I just say it's polynomial, cool, there, I know that's what's going on. I know more than that, but we're not quite there yet. I know about the shape and stuff too, but that's coming up later. Does anybody know, now this guy's good. Why is he good? I think we already said that. Nothing's to a negative power, there's no variables on the bottom. How many terms are there? It tells you, it's one term, right? Terms are always separated by pluses and minuses. So there's really just one term, the 3x squared y. There's no plus anything. What would you call a one-term polynomial? Monomial. Like monocle. Right? One glass, that's a monocle. Monochrome, one color. Polynomial with 2 terms. Yeah, bicycle. So binomial. And a polynomial with 3 terms. Trinomial. Tricycle. Okay, and then past that, we just say, screw it, man, that's enough. Past that, we just call everything else polynomial. We don't want to go quadrinomial and quintinomial and septinomial. No, screw that. That's fine. All right, how are we doing so far? We like it. We love it. So, the basic idea of a polynomial, I mean, if I asked you to create one, you could just go crazy with letters and numbers all over the damn place. As long as no letters on the bottom and they're only to whole number powers. All right, so you could have 4x to the 100th power y minus 7x to the 50th y cubed. Just go crazy. Just create one. Now we're going to move into the coefficients we already pretty much know. So like that first term, how many terms are there here?
4.
Good, I love it. So these are 4 terms. That first term, what's the coefficient on it? 8, I love it. Now, here's your next definition. The degree of a term is just the total number of letters I see. So in that term, I see 2 x's. So the degree of that term is 2. It's a second degree term. You kind of with me?
So it's how many powers, or is it how many variables?
So let me show you a better example, because all that's got one variable in it. If I had 8x squared y cubed z, oops. The degree of this would be, I see 2 x's, 3 y's, and 1 z. I see 2, 5, 6 letters. So I see 6 is a 6th degree. It's that simple. And why do we do that? Because if I had, for example, if I had plus y squared, what degree would this have? This would be a second degree, right? I just see 2 y's. This would be a second degree. So I know that this is like the more important term. It's got, if I change x, y, and z, it's going to change most. Right? If I double my y, my whole term is going to come 8 times as big, 2 cubed. So this is going to change the most. So it's important for me to know what's the highest degree term that I see. So that's why I have to know what the hell is the degree of a term mean. So the degree of that term is 2. I don't know why they put this. We'll get to this at the end. What's the next term?
Negative 5x.
Negative 5x cubed, the coefficient?
5.
Negative 5. The degree? 3. The next term, 1/2 x4, what's the coefficient? 1/2. You with me? So the coefficient is always the number I see in front. And you got to be careful. If it's a minus, that is actually a negative number, like that 5. And what's the degree of that term? 4. You'll love this one.
I have a question.
Yes, ma'am.
Is the degree always the exponent?
The degree, if there's only one letter, then you're right. The degree is the exponent. That's awesome. If there's just one letter in the whole thing, I only see x's. Then the degree is just the powers that I see.
Okay.
The minute I have more than one variable, you have to add those powers together.
First?
Yes. So this term would be 2, 3, 1 would be 5, 6th degree. That term would be a 6th degree term.
Because you added the...
That's a measure of how much it could change, really. It's got all these things together. All of those could change. So overall, it could change at the 6th degree. It's kind of like different belts and karate. Not really. It's not quite as interesting. What about this last one? This is going to be a little weird. Negative 6. What's the coefficient? What's the degree? 1. See, I knew you'd say 1. Where's the one variable you see in the number negative 6? It's a 0 degree. So degree is exactly what I just said. It's all the number of variables I see. If you don't see any, it's a 0 degree. Let me see if you guys can go with me on this. If that makes sense, cool. Let me show you one extra little thing. How many x's are here in negative 6? None. So isn't there like a 0? What is x to the 0? 1. So I could put x to the 0 after anything I wanted to, really. It would be kind of stupid, but I could. Just like I could put a 1 next to everything in the world. Yay, Jeff. What good is it? But that really helps you. If we, like we said, there's only x's. What's the degree? It's really just the power. What power do I see? 0. So every single number, every constant they're called, every number would be a degree 0 polynomial.
So the same as 1, right?
Yeah, x to the 0 is 1.
So
But the degree is the 0 degree. Because I don't see any variables. Cool.
So negative 6 by itself would be the same if it was negative 6x 0 as far as the degree goes.
Exactly. Well, that's true, period. But putting x to the 0 normally wouldn't help me out. Here it's kind of hopefully helping me explain why it's 0th degree. Cool. If it didn't help at all, okay. Sorry. Now, the degree of the polynomial is, I pretty much already gave it away here. I'm always interested, what's the most powerful piece of this whole thing? So the degree of the polynomial is just the highest degree I saw. What's the highest degree we saw? 4. So that is a 4th degree polynomial.
And that's because it's the highest...
The highest degree we saw amongst all the terms. It's a real quick way. So if I say I got a 4th degree binomial I'm working with, that means I know I got 2 terms. I know the highest degree of either one of those terms is 4.
Okay.
I know that's how much it can kind of vary.
Okay.
So later in math you'll learn how that could even possibly tell me the shape of it and all this different stuff. Right? So there's a little bit more. There's a whole other reason why we have these categorizations. I just tell you that one thing and I know a lot about it. I know the shape, I know what it can do, I know how many times it turns, all this kind of stuff. Yeah?
So if you have like, I guess we're going to roll with things that have like terms, you would like simplify it first and then...
Beautiful. I love it. So you wouldn't say 2x plus x is a binomial because, like you just said, you haven't simplified it yet. 2x plus x is 3x, that would be a monomial. I love it. So that's this whole next section, combining like terms. And this is the stuff, this should be old news. But take a minute and see if you can do those two right there. Combine those like terms. Be really careful. Let me help you before you get too far. 2x squared is not 4x. What's being squared here? The x. The 2's not being squared, right? So 2x squared is x squared plus x squared. Just like 2x is x plus x. So x squareds can only go together with other x squares. Do you see what I'm saying? That's the idea of like terms. Like terms means the same variables and the same amount of each variable. And then you're allowed to put them together. Consolidate them. Just make sure everybody's on the right track. What can you put together in this first one? The x squared is good. And then the x's. So you get 2x squared minus 3x squared is negative x squared. 5x plus 6x plus 11x.
That's to negative 1x.
That's okay too, but we don't really need that one in there. Right?
So they don't
So that would be a binomial, the highest degree of polynomials are 2.
That would be a binomial, second degree binomial. I like that. What's that? Now be really careful. I think I know where you're going. There's no equation here. So to get my stuff together, I don't have to subtract or and add and all that stuff. I just put them together. I'm not sure if that's where you're going.
Yeah, but I added my exponents.
Oh. So help me out here. You're probably not the only one. Don't worry.
I got negative 1x.
What's x plus x? 2x, right? Not 2x squared. So x squared plus x squared, if you say 2x to the 4th, I'm going to write a note saying, I don't see any x4s over here. How did you get 2 of them? The only time exponents can change. Oh, this must be a note because I'm talking really slow. The only time exponents can change is when you multiply, because exponents are based on multiplication. So x squared times x squared, x to the 4th. We know we add exponents, right? X squared plus x squared, I just collect them. I got a couple x squares. 2x squared. Second.
They can change when you divide, right? The exponents.
Well, if you want to get into it, division is just multiplication by the reciprocal. So,
Okay.
yeah. Multiplication or division. Yeah.
So is that how you want to write it? Second degree binomial?
Push that over. So it should be 2x squared there. Is that cool? So second.
Is that how you would want the second write it? Second degree binomial?
If I was asking for what kind it was, yeah. If I said what kind of polynomial is this? Binomial, and it's second degree because it's the highest degree I see. Is that cool? What about number 2? What can you put together there? The x's and the numbers. So this poor Jude is all alone. Plus 11x. Careful. Plus 3. So what kind of polynomial is that? Trinomial, what degree? So it's a second degree trinomial.
Are they all called like we would call it monomials and binomials and trinomials?
Yes.
All considered polynomials as well?
They're just specific kinds of
Specific
polynomials.
ones.
Yeah.
They're not just-
Poly just means many terms.
Yeah.
And then we get specific for 1, 2, and 3, and then we got tired and said screw. The rest of them just have many terms. Yeah. All right, and then now this part is definitely nothing here. You've seen this kind of thing before. Now you just happen to know that this is called a polynomial, But it's still just giving you a value for the variable, right? So this should certainly not give anybody any trouble. Just plug a -1 in and figure it out. You've seen those kind of problems before. The one thing you got to be careful about, though, when you have these powers in there,
I have to call the binomial and trinomial. How do we count the term?
yep, just count the terms. So I ended up here with 1, 2, 3. I know there's 3 because they're always separated by pluses or minuses, so there must be 3 terms. And that's why it would be a trinomial. Good. So here when I plug a -1 in, it's twice -1 squared plus 5 times -1 plus 1. What's -1 squared? 1. So now it's 2 times 1 plus, well, minus 5 plus 1. So it's 2 minus 5 plus 1. Yeah, -3 plus 1, -2. So when you plug in stuff in, you got to be careful about maintaining. You got to square x. X is negative, so you got to square the negative also. I always get people have this coming out to be negative at the end. When you square negative, it comes out positive. Okay. So any questions on that? Yep. Let's see. Oh, if you guys want to take a break? Maybe a short break because I'm going to let us out early today. So let's take a short break. Let's come back in 10 minutes. Oh shoot! Of course.